Hello, good morning students. Today we will start our diffusion. What is the meaning of the diffusion? So let's start from here. The spreading out and mixing of a substance with another substance due to the motion of its particle is called diffusion. So in a simple words I am going to tell you one example of it. Like this one test tube I have taken tube. Okay. In this tube I have put it here a bromine vapor. Okay, bromine. And in this one I have taken a empty one test tube. Okay, both the mouth of both the test tube are touched to each other. Okay, this is of bromine is of brown color, bromine red brown color it is. Now what you will see from here, this test tube, from the first test tube it will go to the second test tube, means the full things it will go, bromine vapors will go upside. Okay, bromine this one vapors will go upside and full thing is formed a red brown. So what we are able to say here, diffusion of bromine vapor or bromine gas into air. So what the thing I have explained, that is it is written here. So a note it is here is the diffusion is fastest in gases and slowest in solids. So we are using here about the gases only. Fastest in gases and slowest in solids. The diffusion is fastest in gases because the particles in gases are moved very rapidly. So here it is a gas, this is moving very rapidly. That's why when it is moving very rapidly, it will go very fastly. Okay. Now, if we are talking about the solids, in a solid the diffusion is very slow. Why it is so? Because it will not move much as gases, it will not move much as liquids. So let's take a second one. The diffusion is slowest in solids because, why it is so? Because the particles do not move much. Rate of diffusion increase when there is an increase in temperature. Okay, when the temperature is increased, then kinetic energy is also increased. Okay, increase of spread of particles of a substance increase the rate of diffusion. When the particles of a substance is increases, then the rate of diffusion is also be increases. Okay, now diffusion is of three types. One is of gases, second is of liquids, and third is of solids. Let's talk about first is gases. Okay, diffusion in gases is very fast because the particles in gas move very quickly in all directions. The rate of diffuse of a gas depends on its density. So in a gases, one thing is very important, it depends on its density. Now I am giving some example to you. Here it is written, but I am giving it shortly. The example to you, like when we are making a food. Okay, the smell is going in whole of the room or in whole of the home. Why it is so? Because of the diffusion. Which type of diffusion? It is a diffusion of gases. One person is putting a perfume in a one room, the smell will go outside in a second room, or it will go some outside. Why it is so? Because diffusion of perfume vapors into air. That's why. Now third thing, when we are putting in a Hindi we are saying as agarbatti, but in English we are saying as incense stick. We are putting in our we are doing a puja or we are putting in any place. What will happen? The smell of it will spread in a room where a temple is. Why it is so? Because the particles are collides in all the direction. Or in other words we can say because of the diffusion in gases. These are the common examples which we are using in our life. Okay, next is diffusion in liquids. Now as we are taking the example of diffusion in liquids, we are taking a water and we are using a potassium permanganate and any other thing we are using. So one thing I am going to tell you now, diffusion in liquid is slower than the gases. This you know very well. Gases having more than in liquids than in solids. Okay, if a crystal of potassium permanganate is placed, like this is the water, what the thing is written here I am going to tell you now. This is the water, I have put it a potassium permanganate solid. What will happen? Slowly this solid one portion is changes into leave its particles, and it changes, this watery color is changing into a blue color. When it changing into a blue color, it shows that it fully dissolved and potassium permanganate is fully dissolved. Second example, again we have taken a water, and in that one water, like we have taken a, in this beaker we have taken a water and we have put it a ink now, drop of ink. What we will see, we are able to see this is fully water is become blue in color. Why it is so? Because diffusion in liquids. Okay, next we are using same technique. We are using, we in a beaker we have taken a water and then copper sulfate we are adding in a whole water. What will happen? The spreading of blue color of CuSO4 copper sulfate into water, it is due to diffusion of CuSO4 particles into water. Means is this, in this one beaker water is there, in this one I am adding CuSO4, it takes a color of the CuSO4 because of the diffusion in liquids. Okay, this is understood now, diffusion in gases and diffusion in liquids. After this, the last one is diffusion in solids. Like diffusion in solids, like a teacher has written something on the board, and after 20 days I said to rub it. It is very difficult for a child to rub. Why it is so? Because the particles of the chalk are stick on the blackboard. Okay, the particles of the chalk is stick on the blackboard. That's why it will rub, but it takes too much energy to rub. As we are rubbing daily, by that it will take a more amount of energy to rub. In this one, what I am explaining here, this is. Now in this one, if two metal blocks are bound together, like two metal we have taken and kept undisturbed for a few years, then the particles of one metal are found to have diffused into the other metal. Same thing we are using in solids. Two metals we have taken, remain as undisturbed for a few years. What will happen? They diffuse to each other. Okay, at last there is a one note. What is that note? Is that diffusion is more in gases than in liquids and than in gases. Why it is so? Because of the fixed position, the particles of solid only vibrate about their fixed position. So this thing you can write it in your copies. Fine. Diffusion in solids, this is diffusion in liquids, and this is, you can see, okay, these things you can write it in your copies. And from the book also I am giving to you. From a book you can write it here. If you want to write down, you can make my notes also, or you can take the help of this one also book. Okay, diffusion, then this is diffusion in gases, and this is diffusion in liquids and solids. Okay, and some questions I am giving to you. Those questions you can write it in your copy, and one topic is left. That topic I will cover in this week only, and after that we will start the next chapter. Okay, thank you and have a nice day.